welcome back. Happy New Year to everyone. So in this video, we are going to be looking at linear functions and how to plot a linear function, and we're going to look at some exam questions that involve solving problems using a linear function. So what is a linear function? Well, we've come across this before. This is just the line, right? This is just the line that we have already studied in coordinate geometry. So a linear function is in the form, so fx equals ax plus b. Does this look familiar to you? It should, because this just looks like mx plus c. So that looks like my equation of a line. That's because it is a line. So where a and b are constants and x is my variable. So let's look at some key points of a graph. So this point here, where my graph crosses my y-axis, is called my y-intercept, and that is for when x equals 0. And then here, it crosses the x-axis. That's called my x-intercept, and that happens at y is equal to 0. Other things to note, if a, or the coefficient of x, is positive, my graph is pointing upwards. So we say that this is a positive function because my leading coefficient, or i.e. the coefficient of my highest power of x, is positive, so it points upwards. And if it's negative, it points downward. I should say less than 0. If it's negative, then it points downwards, right? So how to graph a linear function? So we've come across some methods before. So when graphing a linear function, we need at minimum 2 points to satisfy this equation. We just need 2 points. That's it, right? So we can find these points by using two methods. So the first method here is the intercept method, which we've already kind of saw before, I believe. So this just involves finding the x-intercept and finding the y-intercept. They're my 2 points. Plot them out and connect them up. Bada boom, bada bing. So first we find the y-intercept by letting x equal 0, and then we find the value of y when x equals 0. And then let y equal 0 and find the corresponding x value by subbing it into the given function, and that will give me my x-intercept. So, no, we can use any 2 points to satisfy a graph. So if you want to find 2 points on this line, go ahead, right? That is a-okay. So let's look at this one here. Plot the following lines using the intercept method. So I have an equation, I have a line here, right? 3x minus 2y is equal to 6. Now that doesn't necessarily look like an equation of a line that we've just come across above, but that is an equation of a line that is on our curriculum. So like this one here, like ax plus by plus c is equal to 0. You know, so that is technically on our curriculum. But that's just another equation of a line. When we get to quadratics and cubics and all them other ones, right, they're kind of a very set way. But here we go. So 3x minus 2y is equal to 6. So I need to find my x-intercept and my y-intercept. So x-intercept, y-intercept. So my x-intercept happens at y is equal to 0. So 3x minus 2 times 0 is equal to 6. 3x is equal to 6. X is equal to 2. So my point here is going to be 2, 0. Because remember, when plotting points, it's my x value first, then my y value. My next one here, my y-intercept, that happens at x equals 0. So I have 3 times 0 minus 2 times y is equal to 6. Minus 2y is equal to 6. Divide both sides by minus 2. Y is going to equal to minus 3. So 0 minus 3 is my other point. So now I just need to draw out a little axis and plot down 2 points. Bada boom, bada bing. That's it. Done. So I'm being a bit rough here. So remember, when we're drawing axes, you scale them the same. So if you go up in one box on the x-axis, you constantly go up one box on the x-axis. Right? If you go up 2 boxes on the y-axis, you continuously have to go up in 2s on the y-axis. Remember, you can have different scales on the axes. I can have different scales on my x-axis and a different scale on my y-axis, but I just have to be consistent, right? So 1, 2, 3, 4. So 1, 2, minus 1, minus 2, minus 3, plot these 2 points. So my first point here, 2, 0. So when x is 2, y is 0. Boom, there it is. Next point, 0, minus 3. So when x is 0 and y is minus 3. Boom, there it is. There's my 2 points. Connect them up. Bada boom, bada bing. Easy peasy, lemon squeezy. Next one here. Fx plus 3y is equal to 15. So, my x-intercept, y-intercept. So, x-intercept, y is equal to 0. So, where it crosses the x-axis. So, it's going to be 5x plus 3 times 0 is equal to 15. 5x is going to be equal to, well, 3 times 0 is 0, so it's going to be equal to 15. X is going to be equal to 15 divided by 5, which is 3. So 3, 0 is my first point. Next one here, my y-intercept, that happens at x equals 0. So when x equals 0, 5 times 0 plus 3 times y is equal to 15. 3y is equal to 15. Y is going to be equal to 15 divided by 3 is 5. So it's going to be 0, 5. There it is. There's my 2 points. So 1, 2, 3, 4. 1, 2, 3, 4. So 1, 2, 3, 4, 5. Notice how I'm going up in ones. 1, 2, 3, 4, 5. Why my scales are the same. Excuse me. So first point, 3, 0. So 3 on my x-axis, 0 on my y-axis. There it is. My next one, 0, 5. 0 on the x-axis, and then 5 on my y-axis. There's my next point. There's my 2 points. Bada boom, bada bing. And then what we do is we just connect them up. There you go. There is my line. Easy peasy, lemon squeezy. Right. The next way we can do it is a table of values methods. So what we do is we set up a table with these columns. So we set up one for my x values, my domain or my inputs. We set up one then for my workings. So what we do is we sub in my input to my function. We have my range here or my outputs or my y values. So here are my inputs. So I list out my inputs, sub them into my function, list the following outputs, and then I write out the following coordinates or the couples. I plot them on a graph. I plot them all these coordinates on a graph, connect them up, bada boom, bada bing. So let's have a look here. So graph the function f of x equals 2x minus 3 in the domain minus 3 is less than or equal to x, which is less than or equal to 2. So in my domain, so this here is just telling me what all of my inputs are. Well, it's telling me here, well, x is greater than or equal to minus 3, but it's less than or equal to 2. So therefore, x can equal minus 3, minus 2, minus 1, 0, 1, 2. It can't equal anything more or anything less. It's trapped in between them two values. There are my inputs. So here's my second column here. I started subbing it into my function 2x minus 3. So 2 times minus 3, then minus 3. 2 times negative 2, subtract 3, is equal to minus 7. 2 times minus 1, minus 3 is equal to minus 5. 2 times 0, minus 3 is equal to minus 3, etc., etc. And you have for all your points. So here are all my y values. I then just minus 3 minus 9 is one coordinate, minus 2 minus 7 second coordinate, minus 1 minus 5 third, 0 minus 3, 1 minus 1, 2, 1. There are all of my coordinates. So I now just plot these points out. So when x is minus 3, y is minus 9. So go to minus 3 on my x-axis, go down my y-axis. There's my first point there. Minus 2, 7. So minus 2, minus 7. Minus 1, minus 5. 0, minus 3. 1, minus 1, 2, 1. And there are all my points. Connect them up. Done. I just plotted a line. Now, that seems like a bit of an effort, right? And you know what? It is a bit of an effort, right? You have to do it all by hand. What if there's an easier way? Well, there is. We can use our calculator, right? So let me get up my calculator here. So we can use my calculator to create a table of values for us. So I'm going to whip up my calculator here. And here's how you can, this goes for any function, right? This goes for quadratics, cubics, exponentials, any function imaginable, right? We can use my calculator to get all of my points for. So what we need to do is, first here, we need to enter table mode. And how to do that is we click this here, the menu setup. So click that. Then we want to go here. We're going to go over this part. So you can go either go over with your arrows and click equals, or you can just click 3. So here we go, fx equals. So I have been told now to enter in my function. So my function here is 2x minus 3. So let's enter that. 2. Wait a minute, where do I get the x from? Well, if you notice here, we have a red x above my right bracket here, and that's the x we're going to use. So we need to click alpha, because see how alpha is red, red, right? So alpha unlocks all the red buttons. So we click alpha, and then here. So now that will give me my x. And then finally, minus 3. Now it gives you something called g of x. This is if you want to plot two functions at the same time, like, and get two different table values, but like we don't need to do that, so we're just going to click equals. We're going to ignore that. Now it's going to ask me for my table range. This is my input values. So as you see here, my input values are minus 3, minus 2, minus 1, 0, 1, 2. So let's plot these. So it's my input values are minus 3, minus 2, minus 1, 0, 1, 2. So let's plot these out, shall we? So I'm starting at minus 3. You click equals to go on to the next one. I'm ending at 2. And then step, what does step mean? Step just means we are going up in ones, right? Now, when you get to like cubic equations, you might have to go up like in halves. But in this case, we're just going up in ones. So it'd be minus 3, minus 2, minus 1, 0, 1, 2. There you go. Click equals. And there we have it. We have my table of values here. So minus 3, minus 9. There we go. That's my first coordinate. Minus 2, minus 7. Right? And you see, these are the coordinates I was given. Minus 2, minus 7. Minus 1, minus 5. Right? 0, 3. So 0, minus 3. Right? Then you keep going down. You get all of them. You get 1, minus 1, and then 2, 1. Right? So the first column here is your x value. The second column, even though it says f of x, it is your y values. And that's it. That's how you get all your coordinates on a calculator. So I'll hide that now for the time being. So that's how you plot a function. So let's look at an exam question now, and let's see how we can solve problems plotting functions. So a popular way they like to ask is, they'd love you to compare two companies. They'd love you to compare two companies, and like on prices and etc. and stuff. So let's look at this here. So this is from the 2015 GeneSir high level paper. So two mobile phone companies, Cellulon and Mobile, offer price plans for mobile internet access. A formula in X for the total cost per month for each company is shown in the table below. X is the number of MB or megabytes of data downloaded per month. So first company here, Cellulon. Cellulon, and the total cost per month sent is 4x. So it's going to be 4 cents per megabyte of data used, right? And then Mobile here, the cost is going to be 1,000 plus 2x. So it's going to be 1,000 cents plus 2 cents per megabyte, right? So we want to draw the graphs of CX and MX, so Cellulon and Mobile, on the coordinate grid below to show the total cost per month for the domain here, 0 to 700. Label each graph clearly. Now, so 0 to 700. So I'm actually going to go up in 100s, really, because they give you the graph here, and see the X values are going up in 100. If you actually plot out 700 points, fair play to you, but like that's a lot of effort, you know what I mean? So let's whip out my calculator. Boom. So I want to plot out Cellulon. So let's reset ourselves here. So menu, table, fx. I want to plot out Cellulon. Cellulon is, the function for Cellulon is 4x. So I'm going to put that in. 4 alpha x. Then I'm starting at 0. I'm ending at 700. Right? And then my step, I'm going up in 100s. So my step is going to be 100. Click equals. And there you are. There's my points now for Cellulon. So my first one here, 0, 0. My next point, my next point is 100, 400. So 100, 400. That's around, roughly around here. Next one, 200, 800. So 200 on my x-axis, 800 on my y-axis. That's around there. 300, 1200. So 300 on my x-axis, 1200 on my y-axis. So around there. 400 on my x-axis, 1600. So right here. 500, 2000. 600, 2400. And then 700, 2800. Right, and there is Cellulon there. So let me make Cellulon purple. Oop, bit off. There you go. And there is me plotting out Cellulon using my calculator. Next one, mobile. So let's go back now. So table 3. So mobile function is 1000 plus 2x. So that's going to be 1000 plus 2 alpha 2x. So I'm again starting at 0, ending at 700, and I'm going up in 100s. So 0, 1000. So 0, 1000. So there is mobile. Then it's going to be 100, 200. It's there. 200, 1400, which is there. 300, 1600. My other points now. Ding, 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 ding. 400, 1800. 500, 2000. 600, 2200. Right there. 700, 2400. So it'll be 2400. So 700, when x is 700, my y value is 2400. Right. Plot these out. So mobile, I'm going to use a little blue. And there. Right, so I plot out my 2 points here. So let's look at the questions that ask me here. Which company charges no fixed monthly fee? Justify your answer with reference to the relevant formula or graph. So what is a fixed monthly fee? So a fixed monthly fee is just a fee you are paying, right, before anything is done, right? So like it's like when you get into a taxi, it adds on like a $5 if like 2 people get in, right? It's just a fixed fee. It's like a fee you have to pay before you receive your goods or services. So before we received any goods and services, that would be 0 megabytes. So when we use 0 megabytes, what do each company charge? So when we use 0 megabytes with Cellulon, they charge us nothing, right? So they're very much, you pay what you get, right? Fair enough. Mobile here, even though we've used no internet, we're paying for 1,000. What's 1,000 cents, right? So it's like a tenner, right? So we're paying a tenner anyway. So which company charges no fixed monthly fee? Cellulon. Cellulon, because when x is 0, y is 0. Or we can say the y-intercept equals 0. Right, so the y-intercept equals 0. So there's no fixed fees. So usually fixed fees are my y-intercept, or standing charges, or anything of the sort are usually my y-intercepts. Write then the point of intersection of the two graphs. Right, the point of intersection. And point of intersection, that is going to be where they both meet, which is here, which is going to be x is 500 and y is 2000. So sorry, this part is meant to be D here. So Fergus wants to buy a mobile phone from one of these two companies and wants his mobile internet bill to be as low as possible. Explain how your answer part C could help Fergus choose between Cellulon and mobile. So Fergus wants to buy a mobile phone, right? And he doesn't know which one of the two companies to choose, and he wants his mobile internet bill to be possible. So we want to explain out which one is the better option for him. Well, again, like any deal, it depends on his usage, right? So if we notice here, if Fergus uses up to 500 megabytes of data a month, right? So up to here, if he only uses 500 megabytes of data per month, well, he's actually kind of better off going with Cellulon, because see here, Cellulon is always below mobile, right? Up to an x is 500, my megabytes is 500. So Cellulon will always be the cheaper option if you're using up to 500 megabytes of data. It's just when you get after that here, you see Cellulon now is starting to be higher than mobile. So it's going to be higher on the graph. That means that Y values are higher. That means they're charging more. So Cellulon is charging more than mobile when he uses over 500. So how would you help Fergus choose between? Right? So you just say Cellulon, cheaper. If he uses less than 500, mobile is cheaper if he uses more than 500. And that's it. Right. So let's look at two more exam questions, and we'll wrap this video up. So this is from the 2023 Junior Cert paper. So this only came up in the last year's Junior Cert paper. So after the match, 30,000 people left the stadium at a constant rate. The graph below shows P, the number of people still in the stadium, T minutes after the end of the match. The 2 points are marked on the graph G and W. The point G has the coordinates 6 and 21,000. Explain what 6 and 21,000 mean in terms of number of people in the stadium. So, see here, T. So, my x-axis is minutes after the end of the match. And my y-axis is the number of people in the stadium. So, if my y value is equal to 21,000 and my x value is equal to 6, we say in context, after 6 minutes, there are 21,000 people in the stadium. So after 6 minutes, there are still 21,000 people in the stadium. It took 20 minutes for all of the 30,000 people to leave the stadium. Use this fact to write down the coordinates of W, which is on the t-axis. So, 20 minutes, after 20 minutes, there was no one left in the stadium. So, that's what this indicates here, right? After 20 minutes, there were 0 people in the stadium. So, my Y value is 0. So, what's my W here? Well, they said 20 minutes. So, The on the x-axis here, it's equal to 20. So the coordinates of W is going to be 20, 0. So after 20 minutes, 0 people are left in the stadium. Such fun. So, part C, the equation of a graph can be written as P is equal to 30,000 minus 1,500 T. So the P being the population within the stadium and then T being minutes after the match has ended. How many people were in the stadium 12 minutes after the match had finished? So 12 minutes after the match is finished, so T is going to equal to 12. So P is going to equal to 30,000 minus 1,500 times 12, and that is going to be equal to, so 31 minus that's going to be P is equal to 12,000. So there are 12,000 people left in the stadium. So put that in your calculator, 12,000 people left in the stadium after 12 minutes. Explain what the 1,500 in this equation means in terms of number of people in the stadium. So if you notice here, right? If you notice here, so when T is equal to 1, let's say, so every time I increase T by 1, I'm multiplying this minus 1,500 by T. So every time I increase it by 1, I am subtracting another 1,500. So what that mean? 1,500 people leave the stadium per minute. So every minute, 1,500 people leave. So every minute I've increased one. If you were to plot this out, or if you were to look at the graph, or you get the table of values, every time a minute after the match is increased, 1,500 people have left the stadium. So 1,500 people leave per minute. And that was that question done. That was a nice, easy question. This one here, a school can get, this is from 2017 Junior Survey paper, a school can get its electricity from one of two companies, Buzz or Lecky. The graph below shows the cost of electricity per month from each company if the school uses X units of electricity. The cost of Buzz is BX and the cost of Lecky is LX. So there's the two graphs there. One of the company charges a fixed fee per month. Plus a fee for each unit of electricity used. State which company charges no fixed fee. So remember, fixed fees are y-intercepts, right? So fixed fee, y-intercepts, right? And if we look here, Buzz, right, doesn't start at 0, 0. So therefore, Buzz has a fixed fee. So before you even turn on your kettle, you're already paying like €50, right? So answer, so who does not charge a fixed fee? That's going to be Lecky. Reason, it starts at 0, 0. So it starts at the origin point, the y-intercept is 0, etc., etc. That is fine. Write down the domain and range of the function bx as shown on the diagram. So of Buzz, we want to write in the domain and range. Remember, the domain is the list of inputs, range is the list of outputs. So my domain goes from 0 to 1,000. So 0 is less than x, which is less than 1,000, or you could put 0-1,000, that's fine. And in my range, well, Buzz goes from, that's just my y values, that goes from 50 to 300. So my range is between 50 and 300, right? So my actual y values, right? Here they are. That is the range of Buzz. Use a graph to estimate the set of values for which Buzz is less than Lecky. So I'll be going over this in a later video, But when we say a function's less than another function, we're looking for where it is beneath it. So we're looking for where Buzz is beneath Lecky. And if you see here, between these 2 points here, Buzz is less than Lecky here. In this region. See how Lecky is actually above it on my graph. So therefore we need to find this region here, and that is going to be 100 and 800. So when x is greater than 100 but less than 800, that is when Buzz is less than Lecky, right? So when my x value is greater than 100, so it goes this way, but it's less than 800, right? That is when it is less than. Explain your answer to CI means about the cost of electricity from Buzz and Lecky. So what could CI tell us about the cost of electricity from Buzz and Lecky? It's cheaper. So it'll be cheaper to use Buzz between them two values, right? Because remember, my y-axis is the cost per month. And the cost per month for Buzz is beneath Lecky if you use between 100 and 800 units. So it's cheaper to use Buzz if you use between 100 and 800 units. Right, finally we're looking at part D. So part D is find the slope of graph Bx, or find the slope of the function for Buzz electricity. And then part 2 is asking, explain your answer to part DI means what the cost of electricity from Buzz. So first, let's calculate the slope of Bx. So we have two ways we can calculate the slope. We can just use our slope formula, or rise over run. I'm just going to use rise over run because I wanna. So let's look at some good points. That seems like a good point, and that seems like a good point, I think. So connect them up. So let's look at my rise. So I'm starting at around 75. So I'm 75 and I'm going up to 200. So therefore my rise is 125. And my run is, I'm at like 100 and I'm going up to 550. So my run is 450. So slope equals rise of a run. My rise is 125. My run is 450. Put them in my calculator. And we shall get 125 divided by 450. 5 over 18. It's 5 over 18. So my slope is equal to 5 over 18, which is roughly equal to 0.28. So explain what this means about the cost of electricity. So every time we go up 1 unit, we go up 0.28 euros the cost. So every unit of electricity costs 28 cents. So every unit of electricity costs 28 cents. If I use 1 unit, every time I use a unit, I am being charged an extra 28 cents. And that's it to the end of the video. And I hope it was some help. And I'll catch you guys later. Bye.